So if we added a third independent variable, such as whether or not someone exercised, which could also influence happiness, and I had two levels. They either do exercise or they don't exercise. So now I have three independent variables. My first independent variable is whether or not they have a dog. Second one is their level of commitment. Third one is their exercising. I would now actually have three two-way interactions. And a two-way interaction is two because it is only involving two independent variables. So three two-way interactions. One two-way interaction would be between having a dog and exercising. A second two-way interaction would be between having the dog and the level of commitment. And then the third two-way interaction would be between exercising and the level of commitment. So those are three two-way interactions. Furthermore, which we will not get into for this class, I would actually also have one three-way interaction. And that interaction is involving all three independent variables. So it would be a dog by level of commitment by exercise interactions. And we're going to go over that slightly, but those can get really complicated when you're trying to figure it out. So we're not actually going to look at that for your project, nor are we going to really be practicing how you would draw that out. So here's an example of our basic study with the dog versus no dog, the dating versus married. When you're looking at the main effects, essentially you're only looking at the one independent variable and you're completely ignoring the other independent variable. So if I want to look at the main effect of having a dog on happiness, I would take the average across dating and married. So I wouldn't even look at dating and married. So I would look at the averages of those two. So the no dog averages out to 80 and the dog averages out to 80 in this example. So there would be no significant main effect, as I can see, because that's the same number. So there's no significant difference. Now if I'm looking at the main effect of level of commitment, it's the same idea. I ignore the dog and no dog groups and I actually just collapse across. So I'm looking at the average of dating, which would be the 90 plus 70 divided by 2 is 80. The married is the same thing. Average of married, 70 plus 90 divided by 2 is 80. Also, no significant main effect on level of commitment because those are the same values. However, when you look at the cells themselves, which is what you would look at for the interaction, you are seeing a difference. And in which case, if you mapped it out, you would see this X pattern. Now, as we discussed, when the lines are not parallel to each other, you're seeing an interaction visually. Now, whether or not that actually comes out in the data is a little different. They might look like they're not parallel, but if you actually run the analysis on SPSS and it's not at that magical value of 0.05 or less, then you do not have a significant interaction statistically. But just for visually, to give you an idea of what an interaction usually looks like, we're talking about this rule of having the parallel lines. So you want to keep that in mind, is you always want to test it statistically. You always need to have that beloved p-value of 0.05. So in this example, you're seeing that crossover, which would support that there is a significant interaction. If we used bars instead of line graphs, it's the same thing. So this is literally the same data, only it's in a bar graph instead of a line graph. And normally you would use a bar graph for this type of data because your independent variables are categorical. A line graph is more popular when you're having a continuous variable that you would use a line to actually represent how it's changing as the variable changes. But for something categorical, we only have these two levels, so the line graph really isn't required. You'd want to use a bar graph. Remember that the interactions don't have to look the same. This is also an interaction. The idea of the interaction is that we're seeing a different pattern of one variable on the dependent variable. between other levels of that second variable. So in other words, if I'm only looking at the dog, whether or not someone is married, dogs make them happy. It's equal. So that's cool. But then for there to be an interaction, I would need to see that same pattern for no dog, where whatever level no dog is at, it would be the same whether dating or married. And I'm not seeing that. Here, people who are married but have no dog are happier than people who are dating and have no dog. So because those lines aren't parallel, you're not seeing the same pattern. It's supporting that there is a significant interaction. This is another example of an interaction. Once again, the lines are not parallel, but you're seeing when you're dating and have a dog, you actually are happier than when you're married and have a dog. However, when you don't have a dog, married people are happier than the dating people. So they're actually going in the opposite direction. So this would be another example of a significant interaction. Now, this is where you can find what's called as a moderating variable. A moderator will influence the relationship between two other variables. Those two other variables being one independent variable and your dependent variable. So if we're looking at misleading questions and how they might result in more errors than unbiased questions, when we find out that the misleading questions only result in more errors than unbiased questions when the questioner, aka the person asking the questions, is knowledgeable. However, if a person is asking you questions and they're naive, then there is no increase in errors. So a moderator is going to determine the strength of or direction of relationship between two variables. So if we're looking at the main effect is that misleading questions result in more errors than unbiased questions. And there's an interaction where this tends to only be the case when the questioner is knowledgeable. This is not the case when the questioner is naive. Then what is the moderator? And I'll give you a second to think about it. Oh, pause the video. So the idea here is that the moderator is going to be the questioner and whether they're knowledgeable or naive, because they are the ones influencing the direction. When we ignore the questioner, we're seeing that misleading questions result in more errors than unbiased questions, but that is only the case when you have the specific type of questioner. So that would make it a moderator. Now, this gets very difficult, but when you go into graduate school, you'll want to understand the difference between a moderator and a mediator. So a mediator is the other middleman, so to speak. And what a mediator does is it actually accounts for the relationship between two variables. So it would actually tell you how or why an effect occurs. And the difference is so that this way, if you put this in a model and say you had one independent variable being the misleading questions versus the unbiased questions, and then the other independent variable being the questioner, you would see that interaction effect with the data, right? You would see that when the questioner is naive, the values are probably very similar for errors. When the questioner is knowledgeable, that's when you're seeing more errors in responses. So it's the misleading questions are now having more errors only when the questioner is knowledgeable. So that's the interaction effect. When you have a mediator, it actually will completely remove that effect. So it is actually explaining it. So what's a good example of that? So a good example is if I'm looking at years in college and performance, and maybe I find that the longer you're in college, the better you perform. Well, maybe I also decide to measure motivation. And there's people with high and low motivation. And what I find out is when I account for the motivation, it is removed completely. So if I account for people with high motivation, then this performance no longer has a difference. So it's really high motivation that is accounting for the difference, not the years in college. That would be a different type of question, where one is accounting for the effect, and it's related to both the independent variable and the dependent variable. But once you account for this relationship, then the years in college, the IV, no longer has an effect on performance, the DV. We're not going to go too deep into that, but it's something you'll want to familiarize yourself with and read in your textbook, especially if you're going to go into graduate school, because you will definitely need to know that for graduate school. So going back to the factorial design, remember you can have a main effect that is not significant and still have a significant interaction. You could have two main effects that are significant and have no significant interaction. Basically, any one of these can alone be significant and not significant. So there are up to 8 possible outcomes with this idea of a 2 by 2 factorial, which you can see on figure 10.5 in your book. So for example, the first, maybe you'll have a main effect for dogs and happiness, or maybe you'll just have a main effect for relationship commitment and happiness. Or maybe you'll have a main effect for both of them and no significant interaction. Or maybe all 3 will be significant. As you see, there's a whole bunch of possibilities. This is why you want to make it so that you analyze each independent variable as a separate experiment, both on its own for the main effect, ignoring the other variable, and you're analyzing it at each level of the other independent variable for your interaction. So remember, not only do we have the basic 2 by 2 with independent groups, but we can have much more complex situations. We can have different people in each of 4 conditions, in which case if you have 10 people per condition, you're going to need 40 participants because you need a different person in each condition. So when it's between subject or their independent groups, new people must be in every condition. The repeated measures, if we had the same people in all 4 conditions, we would only need those 10 people. However, in that case, we might want to worry about something like counterbalancing, in which case we might want more people. If we think the way that we order our conditions is going to influence their responses, then we have to account for that as well. Then there is the mixed factorial. This is when you have one independent variable that is between subjects and one independent variable that is repeated or within subjects. In this case, everyone would get the repeated measures, but different people would be getting that between group variable. So if this was a 2 by 2, you would actually need 20 participants. So if I'm using this dog and committed relationship, let's say we're making the dog part within subject, right? Because it's hard to give people dating and then have them married, the same people. So let's say we first give them the dog and then we remove the dog. So that's the within. So we can use the same people for that. And then we also need the between subject part, which would be married people versus single people. So in this case, we'd have married people. First we give them the dog, that's one condition. Then we take their dogs away, that's another condition. But that's the same 10 people. Then we get a group of new 10 people that are dating. First we give them the dog, measure it, then we take the dog away, measure it again. So that's why you only need 20 participants. So any part that is repeated, you do not need new people because you're using the same participants for that aspect of the experiment. Looking at another example, I jumped ahead. So let's say we want to see how the participant gender and sexual orientation of people asking for help will influence your likelihood of helping them. So you're approached by a couple and you're asked for directions. And let's pretend we're not New York, where we usually just ignore strangers who walk up to us because tourists drive us crazy.